everyone, and welcome to today's session, Protecting the Power Grid from Cyber Threats, Best Practices from Around the Globe. Protecting the power grid from cyber threats, malware intrusions, state-sponsored attacks, and cybersecurity regulations is critical for utility resiliency. I am delighted to introduce today's session moderator, who will soon be introducing our security experts and setting the scene on the session. Mike Kopczynski is a Utilities Accounts Executive leading the Americas for Cisco. He has 18 years of experience in the utility industry, helping solve challenges across SCADA, distribution automation, AMI, and security. He is focused on collaborating with customers to build out their secure, reliable network to enable grid modernization. But before I hand over to Mike, we would like to hear from you today. Please do make use of the chat box on the right-hand side of your screen to send your questions through to us. We are running for 60 minutes today. However, we will attempt to respond to as many of your questions as time allows. We are recording today's session, which will be available on demand on the Smart Energy International website. And without any further ado, Mike, over to you.
Thanks. Hello and welcome everyone again to our Global Utility webinar. We're thrilled to have you with us today for an engaging session where we're going to explore the latest trends, strategies shaping the utilities industry. Today's discussion are designed to provide valuable insights and actionable takeaways on how to secure the transmission and distribution sites, leveraging your wide area network infrastructure as a foundation for cybersecurity. I'm excited to be joined today by two industry experts, Marcus Smith and Severiano Macedo, who will be able to share their knowledge and experiences across the globe. We encourage you to actively participate through polls we'll be running during the sessions and submitting your questions in the chat. Marcus Smith is a chartered engineer and the Utilities and Renewables Energy Solution Manager in Cisco's Industrial IoT Solutions Group. He has more than 30 years experience in the telecom and IT space, with more than 10 of those years designing and deploying industrial networks across multiple verticals. Severiano is an industrial IoT account executive located in Brazil, helping utility clients with their digital transformation plans by helping to align technology with business requirements. He brings 25 years experience in communications technology. We know that electric utilities are critical infrastructure and they're essential for our daily lives and deeply connected to national security, public safety, and economic stability. Robust cybersecurity measures are necessary to ensure the safe, reliable, resilient delivery of energy. With this being the case, public regulators around the world have taken an interest in enhancing cybersecurity through regulation. Marcus, let's start with you. What trends have you observed with the interaction of utilities, cybersecurity, and regulations?
Great. Yeah, thank you, Mike, and it's great to be here today. So cybersecurity regulations. So particularly, I'm based in Europe. So NIS2, for example, has been top of mind for a lot of CIOs this year. You know, it's just an example of one of the regulatory frameworks. It's obviously designed to force critical industries to adopt a better cybersecurity posture, so better practices around cybersecurity, drive governance, address things like risk management, and also reporting. Reporting is quite important. For our customers, working with our customers, we know most customers are addressing cybersecurity, but they have a much different posture. So different customers have a different maturity as to where they are today. So working with different customers, it gives us that insight really to see what kind of techniques and solutions our customers are using, and actually at Cisco, what do we need to work on to provide them as well. So there's a couple of key areas I think we should sort of highlight. We know that all utilities need to have some kind of asset inventory. Okay, you need to have visibility of what assets are connected to the network. Once you have that asset inventory, you can look at the vulnerabilities. Okay, what vulnerabilities are relevant to those assets? You know, if we know what firmware an asset's running, we know what what vulnerabilities may be relevant to that asset. And then there's the need to start addressing how those assets connect to the network. So looking at zero trust access. So how we can allow those assets to only have the access that they require. Okay, so a standard like NIS2 sets a baseline. Many utilities are already using other frameworks. So obviously NERC-CIP in the US, which we'll talk about shortly, and even the NIST cybersecurity framework. So a lot of different frameworks have been adopted, but obviously the regulatory part of the industry now is forcing many utilities to be able to report on what they're doing. And then the last point from me on this, I think at Cisco, we're all about practical guidance. So the team I'm part of, we actually set up and validate the Cisco validated design. So these are the blueprint designs that we make available to our customers and partners. And it's really how you can start to implement a number of the solutions and technologies from Cisco. Okay, so we're actually doing what we're showing and asking our customers to do. Okay, so we validate them and we stand behind some of the solutions and products that we'll talk about through this session.
And thanks, Marcus. It's interesting when you lay that out, because there's a lot of similarities between what you're seeing with NIS2, NERC-CIP. Obviously, NERC-CIP's been around a bit longer, but it also continues to evolve and get more mature. The baseline is a set of standards that are designed to secure the assets required for North America's bulk electric system, with more stringent requirements being placed on locations that have a higher impact, basically applying a risk-based security model. Looking specifically at the bulk electric system, previously it was heavily focused on securing the perimeter. One of the big changes we're seeing is the introduction of CIP 15. It introduces the requirement for internal network security model. So the foundation of all of this is getting visibility out to the edge of the network, and this provides the ability to develop and understand baselines of traffic flows, which then create the ability to detect a deviation from that baseline state, which is your anomaly detection. You can detect if new devices come onto the network, new connections, software, and just different things that allow you to further investigate what's going on at the edge of your network. Of course, it'll take some time and work to achieve these capabilities. What we're really seeing is to do this, quickly and at scale. That's the big challenge we're seeing with a lot of our customers today, thinking that through. But overall, it's about getting that visibility out there so you can protect, the critical assets that are spread out across a wide geography, into high scale. Severiano, I want to ask you, what are you seeing in Latin America in terms of, some of this regulation and how utilities are thinking about it?
Okay. Hi, Mike and team. Thanks very much for the invitation. It's a great honor to be here with you. I would say hi to our audience as well. And I would like to share that in Latin America, the requirements are a little bit similar to the North America requirements following NERC-CIP and NIST. Okay, I believe that the single difference that we have is that our local agencies, they are enforcing grid security gradually. I think that they are trying to avoid great impact they are trying to dilute investment to avoid great impact on the tariffs. And I think that this allows the utilities in Latin America to make gradual investments. And in initial experience that we had here, some companies start to invest in heavy tools, but they realized that their OT network were not prepared to run those tools. They realized that, hey, we have an aged OT network that's not suitable for the current security requirements. So they run with a significant dilemma. I mean, refresh network or invest on new security tools. And I would like to share a great case that we have with CPFL. That's a global case from Cisco, because they solved that dilemma, decided to invest on both, right? We had a partnership between the security team and the automation team. They realized that they need to invest and replace some switching gears, some network elements, and at the same time leverage the potential of the security tools. And they did it in a very interesting way. They decided for a Cisco architecture that could leverage the network elements, being capable to work at the same time at switching gears and sensors for those security tools. On that way, they can process all the data, analyze all the OT protocols inside the substations before sending data extra to the control centers. So I believe that this combination of OT refresh and new security tools, it's giving the utilities the possibility to do both things with those limited investment resources. Back to you, Mike.
Thanks, Severiano. I think that's that's critical of how this all plays together, because not any of these elements exist by themselves. It's all about doing these things together to achieve the goal you set out of achieving that cybersecurity, getting them more visibility. Marcus, might go back to you, kind of in your global role, trying to put together those best practices. There's some commonality that we see around the globe. What are those best practices? What are they built on, and how do customers take that step in getting that first step towards cybersecurity?
Yeah, that's a great point, Mike. So, we talk a lot about standards and different standards around the world, but fundamentally, from a technical point of view, we're using the same principles and the same kind of underlying technologies to actually secure the substation or secure the distribution automation site. So I guess it's how we take those technologies and apply them in a way to help our customers who are having to report and conform to these various standards. So, being a network guy at heart, networking, good networking hygiene and good network design is probably the most fundamental building block, okay? Having a good network, leveraging a lot of the features that are available in the network, things like segregation of traffic, encryption, basic features like port level security, and actually firewalls. Firewalls are a good tool, but sensible use of firewalls, okay? We don't have to scatter firewalls absolutely everywhere. So again, we try to provide that kind of guidance in our validated designs. And then once we have a good network that is offering a certain amount of cybersecurity posture, we can then start to leverage other tools on top of the network. So IDS, IPS capabilities, and some of our asset visibility solutions as well. So having that good foundation allows you then to build on top of it. And obviously the maturity of the customer as a basic premise, if you can secure the network and provide that basic level of security, then that's a good starting point for any customer. We try to make our validated designs, for example, modular so that customers can consume them in decent digestible chunks, basically, and we're not asking them to boil the ocean all at once, because even from a budgetary point of view, we know customers need to be able to justify their spend. So it's making it a consumable element that our customers consume as they need to as well. So I guess this is a point, we got our first poll now. So if we can put poll number 1 up, there's a question for the audience to answer, just so we can get a quick feel of what are your main drivers for you to secure your grid network. So yeah, if we take a few moments just to answer the poll, and we'll get some results coming up shortly.
While you're looking at that, just a reminder, we do have the chat open if you have other questions for our panelists, or can address those as well. So give a little bit longer to answer the poll here today.
Yeah, I think we got about 30 seconds left for the poll.
And then we'll put up the responses after this that everyone kind of see, where you're thinking, where some of your peers are thinking, and what is really driving, this securing the grid network. Of course, there's a lot of reasons to do it, and it's probably some combination of all of these, but always looking forward to, your input and, what you're seeing.
Yeah, so I definitely like the bottom answer, so good design practice. So that's definitely good to hear. So people realized it's just good. It's good design practice when you're building a network to build it in a secure manner. Concerned with being attacked, yeah, I guess everybody does have that concern with being attacked. Even if you think you're doing a good job on building a good secure network, everybody's going to be concerned about whoever's attacking the network being one step ahead and maybe knowing of vulnerabilities. So yeah, some good answers there, and hopefully they key into what we're talking about today as well.
Marcos,
yeah,
if you allow me to make a comment about take advantage of this feedback from our customers. My colleague has some comparison that he used to say that to realize the importance of the network in this security design, he used to say that someone cannot install those fancy lockers with face recognition and fingerprints in a bamboo door. It doesn't make sense to put fancy lockers in a bamboo door, right?
Yeah.
You need to invest first in your basis, to redesign your network, because at the end, the network elements will be the ones that will protect your assets.
That's a good point, Severiano. And, really thinking about that OT network as, an asset, not only for communications, but it's also a big asset for your security. And maybe that's good, kind of topic to dive into is when we look at the operational technology OT WAN that's connecting all these, critical points in your network, it really does serve as a control point where you get that security information, get that visibility, apply that policy. From where we enter the substation, we need to connect the connectivity out to there. So, thinking about the OT WAN, how is it used, or how can it be used to complement that security architecture? How can it be used as that sensor, knowing that it is kind of the central point going from your utility operations control center out to the substation? It's, a big control point for us. How do we utilize that?
Yeah, that's a good point, Mike. So let me just share a slide. So yeah, obviously utilities are used to having distributed assets all over a particular country. So we are connecting distributed assets via some kind of wide area network. I think one of the key points here is we don't need to separate connectivity and security. Okay, that's quite important. We are building products that have security baked into the actual products. Okay, so having a modular platform at the edge of the network, or flexible platform, sorry, at the edge of the network, that we can then choose to deploy security policies down to that edge of the network, and actually based on the site as well. So obviously a security policy for the edge of a substation is going to be completely different to a security policy we need at a distribution automation site with maybe a recloser or a cat bank controller connected to a small router. Okay, so having a flexible platform where we can centrally create our security policies and push them down to the edge based on whatever the use case is. Segregation of services, we mentioned that earlier, that's key. So we want to make sure over the WAN we have the ability to segregate the different types of traffic. So SCADA, physical security, maybe any kind of other services, AMI traffic, for example. So we need to maintain that segregation across the WAN. Use of encryption is often quite mandatory. In some countries it's mandatory, but most utilities are encrypting their traffic across the WAN. So whatever gateway we're using, we need the ability to be able to apply encryption as well, end to end, up into the control center. And automation. So we don't want to be doing all of this via truck rolls and engineers with laptops plugging in a substation. We need the ability to be able to do zero touch deployment of our gateways in the field. have central controllers where we can onboard those gateways and actually then push the configuration. And then we need to be able to manage the life cycle of those gateways. So configuration updates, firmware updates, spotting when there's things like configuration drifts, maybe someone's changed the configuration, so those type of assurance features. And all of this is really to enable the utility to be more efficient, okay? Less truck rolls required to actually go to site and enable the communications to site. I've got a point here in my notes as well about scalability. So one of the areas that's quite often missed is scalability. You know, we're working with a lot of customers that have huge networks, distribution automation networks running into tens of thousands. You know, it's quite common for us to see networks of 30, 40,000 sites where there's various assets connected. We are actually running a number of large networks, which we'll touch on shortly. So scale is an area that we're focusing on a lot as well. So being able to do this automation at scale, and the concept of having an overlay network to enable us to remove ourselves or be agnostic to whatever that underlying WAN connectivity is. It could be MPLS, it could be fiber, it could be Ethernet, it could be cellular, but it could also be a private network, or it could be a third-party service provider provided network. So the ability for us to have a network that we control running over the top then allows us to have that ability to define our own security on that network and define our own security policies. And the last point around traffic inspection. So as we add more capabilities to the edge of the network, the ability to be able to inspect traffic at the edge of the network rather than hauling it all back to the data center or the control center and all inspecting it centrally on a mountain of firewalls in effect. So that capability to enhance what we're doing at the edge of the network and actually give us more capabilities closer to the actual assets that are in the field. So I believe we've got another poll question now. So I think poll question 2, if we can put that up. And again, yeah, this is asking a little bit more about WAN connectivity or how you're addressing your WAN security today. So I guess some of these answers, they're not necessarily mutually exclusive, but just pick the answer, I guess, which is most top of mind for you at the moment. And we'll have some of the answers coming up in about 30 seconds time. So we know there are typical models today like centralized firewalling and traffic inspection at the edge of the network. So the substation, not everybody's using it. So again, it's flexible. So having a flexible network that allows us to do both. If we want to do central inspection, that's fine. If we want to do inspection at the edge of the network, it's about flexibility, having the capabilities to do what we want. Okay, so here's the results. Okay, so yeah, WAN infrastructure is private, so that's good to know. So it's about neck and neck between private infrastructure and third-party connectivity, which is interesting. Centralized firewalling, yeah, I pretty much expected that. That's pretty much the model today, and not many people do inspection at the edge of the network. I guess I don't know if Mike or Severiano, you got any comments, quick comments on those questions, answers?
Yes, I also note that most utilities, they are seeking alternative ways to optimize OPEX, right, to reduce operation costs. And they are trying to replace some very expensive MPLS contracts to new WAN options. They are trying, as you said, private LTE, local internet providers, and even some low orbit satellites. But as you said, we need to start thinking about moving from a centralized firewalling and push security to the edge, because we are opening several doors in the network, right? When we go through these options, and we need to decide about inspection. Even some utilities are discussing about pushing internet inside the substations. So it is totally possible from a technology point of view, but we need to be attentive with the design, the required design.
Yeah, good point. And I guess there's also the point of as we make our employees more, enable them more and make them more mobile, there's also the need to push enterprise services down into the field. Obviously we want to keep it segregated, but obviously that means there's more need to actually inspect traffic that's coming in and out of a particular network in the substation that's carrying enterprise traffic. So again, it's just flexibility for customers to be able to do that.
Balance and flexibility.
It's interesting we saw such a balance between private connectivity and third-party connectivity in the poll, which is something we see very common that's out there. They're not mutually exclusive. Most customers have a little bit of everything, and makes me think of one of the customers we've been working with on this who has renewable assets that are spread out outside of their service territory. So wind, solar, kind of spread out throughout the country outside of the area they serve. And because of this, they use a wide variety of backhaul technologies. It could be public, it could be private, it could be wired, it could be wireless, different commercial carriers depending on who's available there. And this kind of created the challenge of not only providing that connectivity and getting some commonality across that, but also how do you secure this at the edge? How do you get firewalls out there if that's what you want to do? What's the best security posture so that you can really push the security policy from a centralized location and know that you're going to have consistency out at the edge. So regardless of what that backhaul is, regardless of how it's coming back, those sites are very secured, and you can build that as part of your overall security infrastructure. And this is something they leveraged. SD-WAN was the technology that allowed them to do that. They could push those centralized policies out to the edge, regardless of what it was, and know that they had a common set of features and security posture out there, and then build upon that. So it really fit the need and allowed them to do that quickly. And that's the other thing that they were struggling with, is if they would have to visit all these sites and update something or send out new firewalls and do something on more of a hardware physical perspective, it was going to be very time consuming and cost prohibitive. So it just was a sweet spot that the technology was there to solve the challenge they have, and because of that it was kind of a quick rollout and allowed them to get to the rest of their day job, getting on with the rest of their to-do list. So a lot of good benefit can come from using the technology in the right space. I know, Marcus, you've seen some big rollouts by you. Would you like to highlight any of those?
Yeah, absolutely, Mike. So let's talk a little bit about scale. I mentioned that earlier. So scale is important. It's not uncommon for a distribution utility to be talking at tens of thousands of sites. We've heard figures of 30, 40, even 50,000 sites is not uncommon. So we do have deployments running that are currently, I think one of our largest deployments is about 25,000 sites, and it is actually moving towards, the target is 50,000. We are using automation. We are using centralized platforms to be able to provision those devices connected over cellular, and actually provision basic security policies to those devices at the edge of the network. Okay, so they're distribution automation sites, so they're not hugely complex. There's not a huge amount of devices there, but being able to provide a good static security policy down at the edge of the network is key, and we have to do it at scale. 25,000 devices, that's not something we can do with a truck roll. Okay, we have to be doing it centrally, and it has to be automated. So Severiano, I guess any examples from your area of the world?
Yeah, as I said, the mainly challenge of utilities here is the OPEX constraints, that they need to severely impact OPEX. And as far as this, it have less engineering operating, remote substations, they are being operated remotely. So the automation part of the network is key, right? So although OT networks is more static compared to the IT networks, we really need to be this capacity to manage it remotely, to make some bulk provisioning, bulk maintenance. So I think that this point that you bring is key. So we do need to have a capacity to manage hundreds, maybe thousands of devices and ensure that they will be securely updated.
And I think that challenge of scale only gets bigger and broader as we move from the WAN out to the substation edge. We've got a lot more devices that come into play. The other big challenge I see out there is, a lot of these devices are of different generations. Some are older, some are newer. So we've got to build out an architecture and a system that accommodates all these things, because many of these devices, they're still doing their job. They're performing their function. So as more things get digitized and we upgrade, out to the edge, we have to factor in how we're going to, build that in so that we can continue to get the benefits of those devices, but also monitor for vulnerabilities, know what's out there, get that visibility out there. As we go to the substation edge, what are some of the first steps we can think about in actually starting to implement something that makes you more secure? What are those best practices at the edge?
Great. So thank you, Mike. So yeah, so let's start looking at the substation edge. Let's talk about what we're actually deploying to the substation edge. So let's put a slide up. This is our utility industrial routers. Okay, we design these actually for substations. What we're doing here is we're actually building in the functionality that we need to be able to secure the substation edge. So the next gen firewall, for example, having it actually built into the router and having it provisioned centrally so that we can define whatever security policy we want and deploy it down to the edge of the network. Okay, there's no need to have a physically separate firewall. We can achieve the same kind of capabilities actually at the edge of the network. So we are using Cisco's SD-WAN solution, so software-defined WAN. It provides a very high level of automation, central controllers, and it allows us actually then to have a good view of the entire network. Okay, so and we're going to talk shortly about some of the extra benefits, but one of the key points is actually having a visibility of our assets in the substation. So knowing what we have connected to the substation network as well will obviously allow us then to define the correct security policy. So we have another platform, Cisco CyberVision platform, which we can actually deploy a sensor down to the edge of the network, which also runs actually on the router itself. And this gives us basically, CyberVision will give us a risk-based approach to security. We'll be able to discover and give us visibility of what assets are connected to the network, how those assets are communicating. So obviously how they're communicating amongst themselves in the substation as well as north-south to the control center. And then we provide a risk profile for those assets based on a number of different elements, basically how they're communicating, the protocols they're using and things like that. So we'll provide a risk-based view to basically give you an idea of which assets need priority to be looked at. But obviously part of this I've mentioned before is good design practice. Okay, so having a good network design is essential. And actually at the top part of this slide, you can see the actual baked in features, the security features that we have actually baked into the operating system. Okay, so things like network segmentation using things like VLANs or VRFs across the WAN. So maintaining that traffic segregation, the firewall capabilities, okay, the zone-based firewall that's built into our iOS XE operating systems is quite powerful. And then TrustSec is another technology. It's a more advanced technology where we can actually be very, very granular on our security policies at the edge of the network. We can actually tag traffic from individual devices and actually define a security policy specifically for that traffic. Okay, so it can be as granular right down to the device and the traffic from specific devices as well. So one of the things I just mentioned was our cybersecurity platform called Cybervision. And obviously at Cisco, we're always innovating. We're always looking to bring new capabilities to the edge of the network. And what we've got right now is we've got the capability to actually deploy our sensor, our software sensor that actually monitors traffic within the substation. We have the ability via the SD-WAN solution now to deploy that down to the routers at the edge of the network. Okay, so it's all done and driven from within the SD-WAN controllers, but it's obviously using our Cybervision platform to push that down to the edge of the network. And Cybervision is what really gives you that detailed view of what assets you have in the substation and how those assets are actually communicating. Okay, so it can build up and provide you with a really good picture of what's happening in the substation. And yeah, so Cybervision, as it says on this slide, actually runs, the sensor actually runs on our physical hardware, and it runs as a secure containerized application and monitors the traffic that's flowing backwards and forwards between the assets, as well as discovering the assets that are actually connected to the network. And all of that data is brought back to a central console where you can actually have a view of what's in the network. Okay, so very powerful application, but it's now integrated with our software-defined WAN solution as well, just to bring it all together into a consistent solution. Okay, so I think we've got another poll. So poll question number 3 now. So I'm going to talk a little bit about some of the technologies you've deployed to actually protect your transmission or distribution substations. Okay, so again, these are not definitely mutually exclusive. It's just, I guess, picking the question that more suits what's top of mind for you as a customer and what drives some of your protection of your traffic across the WAN. So OT asset visibility solutions, they're separate solutions that are deployed on top of the network, so similar to Cisco Cybervision, that provides you that deeper asset visibility and traffic flow capability within the substation, or actually from the substation to the control center. Okay, so about 10 seconds left and we'll get the answers. Okay, so yeah, encryption, as I expected, most utilities are using technologies like IPsec to secure the north-south traffic. Network segmentation, yeah, one of the most basic design features you can use, using VLANs and VRFs, and substation firewalls as well. So obviously we're talking about substation firewalls today, but we're talking about it as more of an integrated type of approach rather than a separate box. So I guess Michael, Severiano, any comments?
Yes, I think that some of those utilities invest in asset inventory and asset visibility. They are realizing that they have a bunch of vulnerable devices there. As Mike said, they are operating normally. Substation, they are operating, although they are aged, sometimes based on Windows NT, Windows 10, right? But they are operating, they still have a life to go. That's why the network itself is the one that should protect those devices. They will still be there. Although our tools were capable to detect that they are vulnerable, they will still be there. The OT team, the automation team, they cannot just replace them. That's why the architecture, the correct architecture based on our Cisco validated design, will give us not only the visibility of those asset vulnerabilities, but the capability to protect, to enforce segmentation straight directly on the asset. Back to you, Mike.
Yeah, what I kind of see from that is it's interesting how, they're all required and people are kind of moving to integrate and weave these all together to increase that security posture. Um, different maturities, as Marcus mentioned, and that's where we have to look at. We've got validated designs and best practices, but this starts with figuring out where your company is at today and how do we get from there to that next step. What makes us more secure and gets us closer to that vision. I think automation, becomes part of that, because anytime we're putting in a new technology or new capabilities across the scale we're talking about today, you need a way to do that, easier with less people involved. Not only because of the time it takes, it can be time intensive, but automation helps remove the human error that's involved in doing repetitive tasks over and over again. Marcus, when you're talking about getting this extra visibility to the edge, I'm thinking there's got to be some automation involved in not only deploying it, but what happens once you detect something that's out of the ordinary. How does that come together?
Yeah, that's definitely a good point, Mike. So, I mean, automation is obviously about that day zero deployment of your assets, your network assets into the network, how you can provision those assets, bring them up, onboard them securely. But as part of the ongoing management of those assets, those network assets at the edge of the network, obviously, if we talk about things like NERC, SIP, and NIS2, it is knowing how those assets comply to, have they got the right firmware? Have they got the right config? Has someone been changing the config? Has someone changed the firmware? So one of the areas that we call in some of our management applications, we call it compliance, but it's really compliance around the actual network asset. Okay, we know what network assets we have in the network. We know what firmware they're running. We know what configuration they're running as well. And if we wish, we can potentially apply the right firmware or config back to those assets if for some reason they do get altered. It could be altered by an engineer on site, or it could be another nefarious reason why they've been changed. So that centralized ability for us to be able to ensure the compliance of those assets as well is a key part, as well as pushing security policies and having centralized view of what security policies we're pushing down to these devices at the edge of the network. I mentioned the rollout, so simplified zero-touch deployment. That's pretty much how we use most of our management applications now. We don't expect customers to be doing, sat in a substation, plugging a laptop in to configure a device. The routers will come up, they're powered up, they come up, they will connect to their backhaul network, and then they will connect securely back to the central controllers to be onboarded. And if we wish to deploy other applications, so we mentioned CyberVision as one application we can deploy onto our edge routers. As once they're up, we can deploy CyberVision sensors down to the edge of the network. We can choose where we deploy it. Probably makes sense on the substation edge, but it may not make so much sense in the distribution network because we're only running, a recloser or maybe a CAPBank controller behind a small cellular router. So it's flexible. And all of these platforms are generating data. They're all generating data about, what CyberVision, for example, what assets are in the network and the communication flows. The routers at the edge of the network are generating data as well. So one of the key parts is also to be able to take this data, take these logs, and actually feed them up into central locations where they can be consumed within a security operations center, for example. So Cisco, many of you know Cisco recently acquired Splunk. So Splunk is now being integrated into a lot of our platforms so that we can bring that data centrally and then start to apply rules and machine learning and even AI to that data to be able to give us a better visibility. For example, there are NERC SIP dashboards already available within Splunk to make sense of data coming from the network. There's things like NIS2 as well being worked on. So to give you that visibility, but to be also be able to give you the ability to be able to make sense of the data that's coming from the network. You know, if you're running an embedded firewall, how do you get that data from the firewall up to a central location to actually make some sense of it, and give you those kind of notifications that will help you when you're reporting against NIS2 or NERC-CIP, for example. Severiano, I guess it might be worth you giving us a little bit on one of our reference customers down in Latin America. So CPFL, you mentioned them earlier, and some of the things you've been doing with CPFL.
Yeah, Marcus, I think that to make all of these things that we are discussing here happen, teams, IT team and OT teams, they should work together. The security team and automation team, they should break silos and they should partner to bring a more solid architecture. Without working together, we will not be able to integrate all of these solutions. Investments are limited, and grid security is a journey, okay? Our reference design brings the idea of a foundational phase, but even during this foundational phase, we need to bring impact to the security. Till we keep investment and we will reach a full spectrum security in a final phase. But to reach there, we need to be working together with these teams, leveraging investments from automations team and a security team. That was what CPFL did best. I think that they partnered, they break silos, and they gave this example to Latin America utilities that yes, they can work together, and when working together, they leverage investments and they bring much more protection, much more results.
Severiano, I'm going to come right back to you in a second, then to Marcus. I want to bring in some of the questions we have from the audience today, and I think your answer to this may tie back to the example you're using there. What are some of the biggest challenges that customers face when they're trying to upgrade a brownfield environment?
Yeah, I guess brownfield environments are always challenging because you've got existing infrastructure in place. Obviously, we see a lot of older assets in the substation, especially serial-based devices. You know, we understand it takes quite a long time for utilities to replace those assets. So if we're going to place a router at the edge of the substation network, we also have the capabilities to actually connect to some of those older assets. So we do support serial-based connections, and we can actually transport those across an SD-WAN network as well. So yes, we are very mindful that utilities do have older assets that we have to consider in the network. Yeah, and brownfield can take many instances, many shapes. It could be other third-party equipment in the substation, but that's fine. If we're talking about Ethernet-based networks, everything we provide is standards-based. Okay, so it doesn't necessarily have to be a complete Cisco solution day one, and we can obviously deal with those older, more traditional assets as well.
Mike, I think another point that I would like to add is lack of solid information. I mean, when we talk about edge substations and poles, equipment is spread all over outside the utility facilities, right? It's very difficult for them to foresee what they have in hands. Lots of aged network elements, mostly unmanaged. So when they starting deploying some tools, like cyber vision tools that Marcus said, they start to realize lots of information. They start to realize that they have some equipments and some old assets that require their attention. And sometimes they find severe malwares. And the substation is working, so they cannot just, let's stop the substation to clean malware. No, they cannot, right? So the lack of information in the beginning, I think it's a great challenge for them to dimension the journey of the grid security, right? But from another utilities that are already advanced, and we have some, and CPFL, I think it's a good case. The other challenge is manage data information. They are acquiring, they are being able in a second phase to receive lots of informations about their assets, about their network, about their vulnerabilities, something that they were not used to deal with such much information. That's why our integration tools like XDR and Splunk, like Michael said, will help them a lot to automate this process of data analyzing. I mean, it's very few resources that being flooded by so many data that they are being able to collect. So in the beginning, lack of information. Now at the end, massive information that they need to process. That is my challenge that I see for the utilities in this journey of grid security.
Yeah, one of the challenges I've kind of, come across in this journey is, there's different projects, there may be different project cycles, and they're never going to be perfectly aligned. So it's important to think about, future-proofing, building out the architecture that gives you more flexibility in the future when new requirements come up. Whether it's, NERC CIP or the other requirements, we know things are only going to get more stringent and more requirements. What can you think about that gives you that more flexibility going forward when you are making some of these architectural decisions? That way, if you're doing the network first, the network's ready to add some more security onto some of the cybersecurity requirements. If you're implementing something, that's a cybersecurity control or measure, the network's able to support it and it can grow, as more infrastructure comes out there. Marcus, one question that came in here from the audience is, what SD-WAN or what solution was being used for that network you mentioned that scaled out to 25,000 sites? I think it's a very impressive number. But we're seeing a lot of requirements where, plans are to grow beyond that. So utilities are starting to think about, how do I get there? How do I support this number of devices? With all the new connectivity, more devices being connected, we have to have ways to do that today and grow to scales that we just frankly haven't seen on the IT side.
Yeah, definitely. Yeah, I actually work on with the team that does all the validation testing for that particular customer. So we are actually replicating as much as possible the scale that the customer's actually running at. It's actually a platform called Field Network Director, which is one of our existing controller management applications that's used for managing our small distribution automation routers at the edge of the network. So it does provide that centralized control, onboarding, ability to push central configurations down to the devices at the edge of the network. So it's more of a distribution automation platform, whereas SD-WAN really extends across all of the different types of sites that we see with utilities, and actually adds a lot more capabilities, especially around security. It's more rich around the security capabilities that can be deployed. Like I said at the start of the call, the kind of security policies we want to push to a router at the edge of a substation network is completely different to what we want to do at a distribution automation site.
Thanks, Marcus. We'll try to squeeze in one more question here before we get to the wrap up here. And I like this question because it pulls a lot of this together, and that is, what are the key considerations in achieving effective network segmentation and asset visibility in an operational technology environment to ensure the compliance, resiliency in the energy sector?
Allow me, Marcus, I start first now. I think that the key word here is integration. Okay, I mean, we need to think the picture in a complete view. We cannot start deploying tools that does not integrate with the other ones, and you cannot get those results, those benefits that the business need. We mentioned about cyber vision, and it's a passive tool that's collecting data, analyzing OT protocols all the time, and sending a lot of metadata to our center. But it's a passive tool, right? But it's a valuable, massive information that cyber vision can share with our identity serving engine, our NAC, that will define some policies that may integrate with our FMC, our Firewall Management Center. And with that, with all the context that cyber vision could share with ICE and FMC, we can start creating segmentation and even micro-segmentation with service group text to ensure this impact, this massive impact. That's why I emphasize that integration is key in this time.
Yeah, and I'll just make a very short. I saw the question come in on the chat, Mike, and actually whoever asked it was on the money, right? So network segmentation and asset visibility, they are two key fundamental requirements for you to be able to start to, be able to comply to things like NERC CIP and NIS2 and have a good security posture on your network. You need to know what assets you have in the network and you need to be able to segment those assets into relevant groups or zones, depending on what those assets are actually doing. There's no need for all of those assets to be on the same VLAN in the substation, for example. So yeah, I think the answer was actually partially in the question.
Yeah, that's good. Yeah, as we kind of move towards wrapping up, Mark, you just want to give us in the audience a quick overview of how Cisco thinks of the operational technology network and the grid solutions?
Yeah, so I've put the slide up just to share how we structure our utility solutions at Cisco. So you can see the various areas such as substation automation, distribution automation, renewables, AMI, so advanced metering, and obviously grid security permeates all of those. But we do have Cisco validated designs on our external website that cover all of these different areas and hopefully provide consumable, tested solutions that you as customers can actually use. You don't have to use the whole design. You can take bits out of it and use bits that are relevant. So if we talk about SD-WAN, for example, we have validated SD-WAN in a utility environment with utility protocols, and there is a validated design for that. So we like to talk about what we've actually tested and what we validated and what we know that works. Okay, so that's really the aim of the utility solutions at Cisco.
Yeah, thanks, Marcus. Thanks, Severiano. We've got one final question that we wanted to throw out there based on what you heard today. And that's simply, if you would like to have a follow-up discussion with one of the experts you've heard talking today, you can just opt into that so we know, to reach out to you. We do thank you for joining us today. Hopefully it's been insightful and we've delivered on the objective of having a thoughtful discussion and some actionable takeaways of how you can look at securing the OT environment and the grid. Thanks again, Marcus and Severiano, for sharing your time and experience with the audience.
My pleasure.
Great. Pleasure. Yep. Thanks to everyone for joining.
Okay, I think that concludes our final poll for today. Thank you, Mike, Marcus, and Severiano. It was a great pleasure having you share your insights and stories with us today. And thank you, audience, for joining today's session. If you asked a question and we didn't get an opportunity to respond, we will make every effort after the session to follow up with you. I'd also like to remind you that a recording of today's webinar will be available on demand on the Smart Energy International website. On behalf of Cisco and Smart Energy International, I would like to thank today's experts and you, our audience, for your active participation. We look forward to seeing you all again very soon.